Hello everybody, this video will present CDESF, a tool for concept-driven detection in event streams. First of all, you have to go to the repository and clone the code into your local machine. You can use the code git clone and the link which is provided on our demo paper. Then you can open your folder with the code of CDESF and first create a Python file where we will use to show how the CDESF works. By opening the file, the first two things to do is to import the read event log read CSV function and then the CDESF object. So to read the file, you have to pass a path and the file name, which is ultimately your event log, and then we can use read CSV. And to instantiate CDESF, we have a few hyperparameters which are explained in depth on our demo paper. Most of these parameters regard the online clustering step. Finally, we can run CDESF using cdsf.run and pass the event stream which we just read. You can see here the event log we are going to use in this test, and then you can go to the terminal and run using the Python command and run the file. You can see the results being placed under the metrics and visualization folder, and while the file is being analyzed, you can see already drift alerts pointing out the string position where a drift was detected, the cluster, and also the cluster characteristics. Finally, we can investigate more of our drifts. First, on the visualization phase, we can see the number of cumulative drifts detected in the string and also the drift's position represented by the vertical line. Moreover, we can investigate the evolution of process model graphs, which are being constructed and updated during the event stream processing. We can also investigate the feature space, where the points or our cases are being placed on the online clustering step. We can see the black points represent normal cases and the yellow axis represent anomalous cases. The black ellipses represent common behavior, which are the microcluster detected by our online clustering algorithm. Here we have an example of a concept drift being detected, the same one we saw in the console output. Here the drift was detected. Also, we can see the metrics evolution. So first we have the process model graph also in a JSON format, which can be ported into our other applications very easily with various characteristics such as weight and the time between activities. Also, we have case metrics. We can see that the case metrics have labels such as normal or anomalous. We can identify anomalous cases during the stream processing. And also, we can detect incomplete cases and analyze them. And finally, we can analyze the cluster evolution. Here we can check various characteristics of the cluster, and we can also identify the cluster position where the drift was detected. Here we can see there is no cluster, and then it appears as an outlier microcluster. Then it evolves into a potential, and finally a core microcluster represents a drift, the same one as the console output. Thank you.